Just appreciate that crusty-ass guitar solo. Very awkwardly and off-key kind of just hit. It hit different than the remastered version, that's for damn sure. Oh, God, hi everyone. Are y'all ready for stream? Are you ready for a big heaping pile of brown? Because that's what you're gonna get today. And for once, I think brown is actually the color that he's going for. Explosions&Fire is going for with chemistry. Usually brown is a color that means you burned your product, but I think this one actually is meant to be brown. So like, it's gonna be it's an interesting moment. Usually it's like, oh, my product's brown. Yeah, I haven't like washed all of the garbage I accidentally made out of it. Here it's more like, I don't know, hopefully it's good, and I think that's usually what he ends up doing. Maybe if Night Dive remasters Wolfenstein 3D into a not-so-jank modern port, that'll be the time. Yeah, you know, maybe Providence will once again fall upon me, and once I finish Doom, there will all of a sudden be a Wolf 3D Master imported straight into the Doom 1+2 port. It'd be pretty rad, honestly. I'd like to do that. I mean, I'd like to play some of the more, well, quote-unquote modern Wolfenstein games. They're no longer modern. They're like 10 years old, but, you know, playing New Order, New Colossus would be cool at some point. Oh, but anyways, hey, how about we get this like show going over here? Let me swap windows and get the big chemistry up, and then also get me up on stream. That's not the right one. There we go. Hi. There we go. It's me. What's up? It's your boy Crash, and we be watching stuff today. So yeah, I guess to catch anyone else up, I mean Tom here's gonna catch everyone else up, but this is Explosions&Fire Tom. Say hello. He is chemist. He does he's Australian, which is very important. And he does exactly the kind of backyard shed chemistry that you think an Australian man on the internet would do. Well, maybe not the illegal stuff, just the legal parts. And he is on a quest to make a big cube-like molecule called 1,4-dicarboxyl cubane. And he's done it once before. He just wants to do it once again at a much larger scale. Because he got like a pittance, a couple milligrams last time he did this, and that's like, you know, yes, technically he succeeded, but it kind of falls a little bit flat when all you have to show for several months of work and many dollars down the toilet, and several grams of initial compound also down the toilet, that you only get like a couple of milligrams of this compound. So yeah, he be making more, and he does great, weird ass, questionable decisions like making kilograms of bromine without much safety equipment. So I'm here as your chemist and chemical safety person, those two things that I am in the real world, to watch some chemistry go down and maybe comment on it a little bit, because that's the kind of thing that I like to do. And I also have a little drawing corner, so look over there for when I have stuff to say. Anyways, let's get the slop on.
G'day, welcome back to the big Cubane series, the series where we're
I love how the GameCube intro is getting faster and faster every intro.
Carboxyl cubane because it's cool, and if we have a lot of it, we can do some cool experiments with it. We did this whole scheme.
Yeah, Graham, I saw your image. I was considering putting the fan art, but maybe next stream. I just didn't have time to save it.
And where we are at the moment is we've completed step 3, which is good because step 3 was one of the more complicated steps. I was really
the deadliest step.
Up, but we have quite a bit of this tribromo product, which is the end of step 3. So now we have, I don't want to say the word easy, but let's say simple. 2 simple steps and then a really hard step. So we've got step 4 and step 5. Hopefully we get these done reasonably quickly so that we can move on to step 6, which is the really difficult step, the step that will require some engineering and some luck and, you know, some favor from the gods. Whereas the other 2 are reasonably straightforward.
I am very much looking forward to that step that he is dreading, because, man, it was terrible the first time.
And we get rid of a
It
lot
took
of
him years to perfect
bromide,
it.
and we end up with this material, which
Gotcha,
when
gotcha,
we
Grim.
ran it last time,
Sounds
just
fine.
worked straight away and made a really nice pure product. And then we have this step, this double deprotection step. This step takes a little while, but it seems to work pretty well, and the product we get was reasonably pure and well, I mean, actually wasn't that pure, but it purified out pretty well from what we saw. So I am not too worried about these steps. But
yeah, these steps did go well last time he did them.
Don't
so
worry
like,
about that. Sometimes catch you out. So you've got to do these steps good and well. So
and,
we
you
have
know,
lots of material to start.
realistically, scaling things up can present challenges that are not seen at the smaller scales, right? Like they molecule or reactions require or produce heat depending on just what the exact reaction is, and if the reaction produces heat, then it could get kind of awkward going up because of runaway heat, because volume and surface area do not scale at the same rate, and that could be a pretty bad feedback loop to get stuck in. Or it could be a reaction that just keeps taking away heat, and therefore you also have a reaction that just absolutely takes forever to go through because of just how poor it's going. So, yeah.
Step 6 with, because if we can nail step 6, I'm really confident in this whole procedure, but we need to make a lot of stuff and get to step 6 well. That's our goal. So yeah, that's it. That's the whole introduction. Let's get on to do some chemistry, because
He's not actually gonna
originally said
draw out the chemistry this time. I might back up then, just so I can
at the end
draw out
the
the chemistry at hand,
which is in mid-July, and it's a little bit optimistic to think that we're still going to make that, but
yeah, no, you're not gonna do all of this in negative 2 days at this point, Tom.
It starts with nailing these next 2 steps. Let's just hope we do good. Let's just not stuff it up, all right? Let's get on with it. Let's get on with it. Here we are. Not only is this one of the...
Okay, so let's back up for a second as I go ahead and actually explain some of the chemistry at hand. And I'll put the music back on too. Why not? I'll rewind it in case it takes me a while to explain. Alright, so what Tom's going to attempt here is the next step in the reaction. The next step in the reaction is going to be this, step from the tribromo product to this diketal product. Now, you might look at this and say, how the hell is he adding only sodium hydroxide and all of this mess is happening? Well, I will do my best to draw out the mechanism with a mouse that I'm still getting used to the feel of. So, let's just draw our product here, or our starting material here. So, God, this mouse really is hard to use. I do still have my old mouse. I might switch to that in case that's a little bit easier to use. Yeah, in fact, hold on, sorry. One moment. Need the old mouse. I had to swap mice recently because the, while I did still like my old mouse, my old ergonomic mouse, the problem was just that it kind of started not clicking some of the times. Like, there's maybe like a 5% of the time the click did not register. So, even though I was very much used to how that mouse handled, came up the issue that, like, it's kind of inconsistent for gaming purposes. Anyways, the old mouse is now plugged back in. It's slow. I guess I could have just lowered the DPI, but this still feels more natural to me. Anyways, so let's start drawing. So we have bromine. Drawing this. We have 2 bromines here. And then we have the ketal group, which is defined as these kind of 2 oxygens sticking out of a carbon. I guess for anybody not familiar with the quick chemistry nomenclature or drawings, every one of these corners is a carbon with some number of hydrogens attached to it. Anyway, so we start with this product, or we start with this molecule. What happens is that when sodium hydroxide is actually added to it, sodium hydroxide acts as a strong base. And you might remember from your high school level chemistry that bases are molecules that would like to suck up hydrogens off of a molecule. And that's exactly what's going to happen here in this reaction as well. Have we learned how to turn rubbing alcohol into goon yet? That's the other guy. You want to go look at that channel. Hey, D, what's up? I'm just explaining the reaction mechanism for the day because Tom did not actually want to explain it in this video. So, we're currently going from that, over here in red, the tribromo product to this diketal product. That's the first reaction we're going with today. Starting off by adding the sodium hydroxide. So the electrons in the sodium hydroxide go and attack this proton, or hydrogen. You're going to hear me go back and forth between those quite a bit. And then what happens is that the two electrons that make up this carbon-hydrogen bond right here, those are going to go in between these two carbons to form a double bond. And it does that because the bromine is electronegative enough to take up the reaction, or the electrons in this carbon-bromine bond and leave as a bromine minus anion. So, effectively, with all that gobbledygook I just said, you end up resulting in a molecule that looks like this. Draw the pentagon nicely again. Pentagons are not very easy to draw as a chemist. You get so used to drawing hexagons that all of a sudden pentagons just become just completely different because of the different angles that they lie at. Let's see, we do this. All right, and then the other things we have here is a water molecule as a byproduct. And then we have the bromine minus, which, I mean, I guess in this whole schema, the sodium hydroxide does have the sodium pair here. So, sodium, and then you have sodium bromide over here. So, yeah, basically, that's what the sodium hydroxide is doing. It's pulling these hydrogens off, and it is causing the bromines to leave, as well as, and leaving carbon-carbon double bonds behind. This happens 2 more times with more sodium hydroxide, so times 2, and you end up getting this molecule over here. Let me make those actually connect up. Bold of me to assume I could draw 3 carbon bonds at once. And then, yeah, so you have the other one. The other double bond is over there. So I gotta draw this with, like, good spacing, so you can kind of see what's going on here. Okay, so you got those 2 carbon-carbon double bonds left over on the molecule. Okay, actually this only happens 1 more time. My apologies. I got a little overzealous. Come on, click. I just switched over to the old mouse, so it's, maybe not, doing so hot. Let me erase that. Okay, and we go again. And then we're left with one of these bromines left. Now, if you're curious, class, pay attention now. If you're curious why there's still 1 bromine left and we only have all this space left over, that's a good thing to think about, because there is still 1 hydrogen left over on this carbon. You know, this carbon up here normally comes with 2 hydrogens attached to it to fill out its all the electrons it wants in its orbit. Now, the reason another sodium hydroxide doesn't come and take this hydrogen and this bromine off is because of the bond angles left over. If it were to do that, you would then end up having a carbon-carbon triple bond in this molecule. And carbon-carbon triple bonds want to be, they want to have the other atom that they are connected to be 180 degrees apart from each other. And even within this crude drawing here, this is not 180 degrees. That's not 180 degrees. That's very, very bent. And nature is just objecting to that wholeheartedly. So you kind of stop at this halfway point. And now, lastly, how the hell did these two other molecules attach to each other? Well, or how the hell did two of these units actually attach to each other to get to this so-called diketal product? Well, what happens is then that what's called a diels-alder reaction takes place. And basically on a simplified level, the diels-alder reaction formerly, first referred to actually this reaction where you have this 1,3-butadiene reacting with ethylene to form a molecule of cyclohexene with one double bond left over. And it basically would go like this, where you would have the double bond fill in kind of this crudely... I'm going to try and draw a crudely dotted line here. Wish me luck. Fills in this space between these two carbon atoms. And then the other double bond here fills in this space between these two carbon atoms. And then the other double bond here fills in this space that's already between two bonded carbon atoms. Why does it do this? It's just... it's favorable for the carbon atoms. The nature of thermodynamics appreciates carbon atoms having 4 other atoms to partner to that are all at 109.5 degree angles from each other, approximately. So that of a tetrahedron. And while they're in this double bonded state, they more like have bond angles of 120 in a plane. And so that's less preferable. And the carbons just kind of want to, stretch their arms out and relax a little bit. And doing this reaction would allow them to do so. Probably just copy this off to another page. That's a very well-drawn diels-alder reaction. I don't want to just delete it. Let's see. Paste it here. Make it go away. All right. So basically, the same concept happens again with just a more complicated molecule. So we go ahead and this is going to be... These are always hard to draw because there's just so much going on. But you basically would have another one of these molecules. Oh, this is very crude. Have another one of these molecules. Let's see here. This bond goes here between these two carbons. This bond goes here between, these two carbons. And this bond goes here between these two carbons. No, wait, not quite those two. Right? Hold on. I'm checking my own thing here. It's hard when it's not actually drawn properly as, a circle. Moving that there because, yeah, no, it wants to have a bond with this carbon, and that means that electrons have to move out of the way. And while I didn't draw it very well, it does kind of come out to do the same thing as, this reaction that I just drew over here, where you have the circle kind of form, and you're left over with one bond, and so you get that final product that, Tom has drawn in his view. So I will sketch out real quick. Okay, we got the one, and then we have this mess. Is a very good thing the chemists are not tested on their drawing skills as a prerequisite to graduating. We would all fail. Even the prettiest among us have quite a bit of a difficult time. But yes, so then it forms this reaction. That's the first thing that he's going to do today. And now he can actually get on with the rest of the funnies because I've done my educational bit. Alright, let me turn off the Mega Man Zero music. And let's get back to this. Get back to the show. Let's get back to where we were, and here we go.
Let's get on with it. Let's get on with it. Here we are. Not only is this one of the most reliable and easiest steps, but it's also potentially the cheapest step because we're just
cheapest
our material with sodium hydroxide in ethanol. Now, I can get ethanol from the hardware store. This cost me a little over $5 for an entire litre. It's 95% ethanol and with a little bit of denaturants in it, so you can't drink it. Doesn't stop everyone. There's no methanol in it, because I think
I just distill it, you know.
Put methanol in it.
Get the ethanol
people
out.
That would drink it anyway would then get severely blind and poisoned from it. So now it's just very unpleasant. Anyway, what am I saying? Sodium hydroxide. You need about 100 grams of this. I'm going to use a whole litre of ethanol, and we have our material here, which has been sitting in the alfoil just so it doesn't decompose so much in the sunlight.
Oh, it's light sensitive too. That makes sense. Light tends to not interact with halogens like bromine so well.
Yeah, I can't do maths, but yeah, sure, there's some amount of it in there.
It makes it want to just form bromine gas again.
Reflux in this 2-litre flask. We've got to add the sodium hydroxide to the ethanol somewhat slowly so it doesn't all overheat. So I'll add half of that right now. No delays anymore. We're on a bit of a timeline. Let's do it.
A bit of a timeline, he says.
Fucking had to spill some of these, didn't I? I'm trying to be cool. That's my problem.
No.
I'm trying to be cool. Really
lost like a milliliter of ethanol. All is lost.
For once in my fucking life.
Australia has fallen.
Instead of cool, but no. Gotta do it with flair. Immediately goes yellow. What's new?
Yeah, that's supposed to happen, Tom.
Okay, so I've dissolved 50 grams of sodium hydroxide. It takes a long time for the sodium hydroxide to dissolve in the ethanol, and I'm still not entirely convinced it's all dissolved. It took about 2 hours.
It's probably not. I mean,
at this point. Got another 30 grams.
Ethanol's still too organic.
Sodium hydroxide. The amount of sodium hydroxide.
I mean, you're making sodium ethoxide right now.
Sodium hydroxide basically in that ethanol, and that's why I'm not really caring too much about the ratios. All right, let's talk about our brominated stuff. We have, from the last video, made 170 grams of this tribromo ketal.
Hooray!
Look at this. So I don't usually do this, but I noticed after last episode we got okay yields, but not great. But then I was adding a bit more water to the old bromination solution, and a little bit more product was crystallizing out. So I continued that, and I ended up getting another 76 grams.
Holy shit! He actually managed to salvage more out of his waste.
You could say it's a little bit more impure, but
that's something he should do.
Actually, it started oiling out a little bit, which is kind of a sign of it not being super pure. So I ran a recrystallization from ethanol, and to make sure it crystallized out nicely, I used a little bit of this nice product to, seed the crystals. I actually used quite a bit of it. So all up, we ended up with
that's a common technique. I've done that before for my research.
Grams of tribromo, which brings us to a 66% yield on the bromination step, which is much nicer. So
that's a little bit. That's like into the barely acceptable territory
for this large scale cubane situation, and it all should be able to go into this flask. It was a bit weird doing like cubane chemistry off camera for this. Actually, it was pretty uneventful, but during the recrystallization, so it was hot ethanol with a lot of this tribromo dissolved in it. Some actually splashed on my hand, and I was, these are my nitrile gloves, and these are my sort of shitty, cheap latex gloves, which I occasionally use for chemistry, but generally just use and throw away a lot because I've got to like touch a phone and a camera and lots of things. Anyway,
I mean, are they really that much more expensive than the other
stuff? Just instantly penetrated the glove.
Oh, that's nice.
Didn't hurt or anything, but for the next 2 weeks, I had these horrible bromine stains, like bromination.
Oh, brother!
On my hand,
I mean, the bromine stains are bad too. Stains are bad too, but have you tried moisturizing a little bit? Like I'm like kind of a lotion denier myself. I don't use lotion on my hands, but I can get away with it because I don't live in the hot Australian sun, dude. Oh my god, his hands look like he's like, a 55-year-old farm worker and also covered in shit.
stains, like bromination stains on my hand, which I wasn't too impressed about. So yeah, I got to be a bit better
So it
at
is
wearing the better
honestly
gloves. I mean, we
impressive
might have
considering
penetrated
that
these other gloves anyway.
there wasn't actual bromine in his workup, or at least there shouldn't have been in his waste from the last reaction, but it still managed to stain his hands full of bromine. It's pretty impressive.
But yeah, it's not often I end up with physical scars from the chemistry. I've got to say, god damn. Did fade, you know, skin's pretty good, and I don't think I was poisoned that much. But anyway, pointing it out, as soon as you do something off camera, it's kind of, I'm like, now nothing exciting will happen. I'll do this all off camera, and then instantly injure myself. It's fine. You don't want to see me get injured on camera anyway. It's fine, it's fine. All right.
Wrong. People tune into Jake Paul and Jackass for that kind of thing. We all love that.
Now I definitely not going to get injured for the rest of this video, because if I do, then that sentence will come back to haunt me. Let's get the rest of this sodium hydroxide dissolved in this goddamn ethanol, and then, yeah, we'll just add all of this. We need to reflux for 3 hours.
I feel like making so much sodium ethoxide beforehand.
A large amount
not,
of water.
Not a great idea.
Wash off the sodium bromide, which is a byproduct.
Like, it's just, it's kind of air sensitive. Like, I feel like it's gonna start making weird side products.
Got to actually find probably a literal bucket, so I'll do that. But apart from that, I think we're all good for a montage. So I'll see you on the other side of this. Bloody hell, let's go. Let's get this done.
Clearing the reaction zone. Oh, of a spider. Lovely Australian chemistry problems.
Come on, little guy. No, you can't. You can't live here. No. No. This is gonna be heated. It's gonna be heated. You can't live here. Come on. Come on. Oi. Mate, come on.
I guess the spider doesn't speak Australian. Maybe if you tried, like, Italian or something, it would work. Boy, it's already brown, and we're not even making the cubane yet.
Calm thoughts.
Okay, maybe he actually did add it in. I must have missed it. But yeah, he boiled it. And now, okay, so this is an interesting thing. And I'll honestly say, doing this as a chemist, like, personally, pouring off my sludgy whatever product into a big old vat of pretty pure water never feels good. Like, it feels like I'm actively polluting something, and I don't like that feeling. Even though I know it's like, okay, water is just another reagent. It's just the most abundant one you can get. Like, it still feels wrong. But what he's doing here is basically that, like, let me see if I can't pull up another layer. He is taking his product, which is, I'm not going to draw it all out again. We would be here forever. But he's taking his product, which is dissolved in ethanol. So let's see. I'll just draw it as this to say that it's in ethanol. And it is, you know, an organic product, meaning that it is made of carbon and hydrogens, and it is therefore oil-like. Or otherwise non-polar. Meaning that the electron distribution is relatively even within this molecule over here. There isn't a strong... oh, it's because I'm on the wrong layer. That's why nothing was drawing. Okay. This is a largely non-polar molecule, meaning that the electron distribution is roughly even. There's no, like, big positive or big negative side to it, which is unlike water, which does have a big positive and negative side to it. So if you add your product to water, which does have a pretty large positive and negative side, meaning, well, specifically, the hydrogen side is roughly positive and the oxygen side is roughly negative. the product is not going to want to stay in solution anymore, especially because ethanol actually can mix pretty well with water, all things considered. Ethanol does have some rough negative parts over here. Slightly negative oxygen as well, but it's just not that pronounced. But it will mix with water perfectly, as all of your alcoholic beverages do. So once that basically you're just introducing the product to a bunch of water, it will not stay in solution. So it crashes out. Haha. Of solution. Meaning that, because crashing out is a old, well-timed, tested chemistry term, meaning that it is going from dissolved to not dissolved very rapidly. And that is exactly what's happening here by adding a bunch of brown sludge into a pitcher of water. It's the forbidden chocolate milk, once again.
2 stir bars.
2 stir bars?
2 stir bars in there?
You added 2, Tom? Nice. Just didn't see the other one. Oh boy. This is the downside of a big water crash out reaction. This is gonna take him forever to get done. This is the largest filter flask that he has, and he's gonna have to do this like... Oh god, there's even more water. It's probably gonna take him like 20 plus filters to actually get this all done. This is like an all-day kind of project. Oh, look at that. That's actually a nice, pretty color.
That, we're left with this bright orange powder. Sunlight absolutely beaming in. It's not meant to be orange. It's not good that it's orange, actually. Even our previous runs, we called it a slight beige color, a slight off-white. This is bright orange. I do have my old stuff. I believe this was...
Yeah, that's pretty different.
It looks pretty good. And Chemiolis sent me this sample, a couple of samples that he made, and I think he recrystallized his as well. But anyway,
let's see what could possibly happen. Maybe there's still some sodium ethoxide kind of left around in there,
which is reasonably reminiscent of the starting material. So I think that's what's happened, is we just haven't had a complete reaction. It's still quite wet as well, but
I guess that's easy. Though I don't think the original product was brown.
Same reaction again, putting this in the ethanol, adding more sodium hydroxide, and refluxing it for longer. Because if this is just tribromo left in the product, we can convert that into the product and also clear up the product of all this stuff. So,
but this is what he was afraid of. Scaling stuff up does have its issues.
There's a reasonable amount here, but yeah, it's just...
I bet when he did the ethanol,
also a little bit more. I mean, filtering all
God.
this was obviously quite difficult, so I'll let a lot of
There's still more fuck.
And then pour
Yes,
out
I was
all
saying,
this, and
I bet when he let the
stuff
ethanol
through that was just
dissolve all the
most
sodium
of it
hydroxide on a small
still
scale,
a little bit left
the
in
amount
here, so
of side products was negligible, but by letting it sit for so long, an air-sensitive solution like that probably stopped being so useful.
Should be reasonably dry before doing that. It doesn't have to
Stop
be
being so
particularly
pure.
anhydrous or like completely anhydrous, but having a lot of water in that refluxing reaction might cause some weird products to form, like breaking off those protecting groups off the top or something, which I'm a little worried about. So yeah, just get this reasonably dry without decomposing.
Oh yeah, no, that's a good point too.
Just do it all
You could
again. Do it a second time. Hopefully it comes out better.
with the extended reaction time needed, he could be accidentally cleaving this group off, which is mostly base resistant, but given enough water and time, it could split off to form the ketone group that he's looking for in a later reaction. Not this one, though. Ooh, some nice crystals, though.
Yes.
Very pretty.
That,
Something pure.
With, I mean, it's practically the same color. I was
More
going to
brown.
Say it looks a little bit better, but honestly, it might look even a little bit worse. Less orange and more brown. What's the technical term for this? Pooey. You know, it looks like shit. Yeah, look, I could run a recrystallization. I think it should be okay. It's a little bit more crystalline than it was before, but luckily we didn't lose too much yield. It doesn't look like in this redoing the reaction with the same material. I need to dry it out quite well before I weigh it, so I'm going to have to put it in desiccator overnight. But yes, so recrystallization, I could do a recrystallization to purify it, and this is what I've done. in the previous series on the smaller scale. But the next step, when we're making the double deprotection molecule, so we're putting in concentrated sulfuric acid, I think we should do the purification after that step. That will stop us losing some product in our purification.
It makes sense.
Step.
You don't really
And
need
the
very
next step
pure
is
molecules
so
to do the
I think any tarry
diels-alder
like
chemistry.
Burn up by the sulfuric acid. Anyway, that's what I'm optimistically thinking. We're going to have to do the purification there anyway. So I think.
Oh well, no, he's going to do the acid chemistry. I don't know about that actually.
Tarry. There's a hint to what might have happened in the 1989 Navy report, which we reference quite heavily.
The original literature.
It says that if tribromo with even 10% of dibromo is used in this reaction, the final product is dark and tarry, or something along those lines. So I think I got a little bit greedy, and when I separated off more tribromo and said, oh, the purity is a little bit bad, but it should be okay. I think that probably had a significant amount of dibromo in it. And when I say significant, I'm saying, maybe 10, 15%. So overall, 10% of the dibromo has led to this product being quite dark and tarry. But I think the majority of it is fine, so we should just keep going on to the next step. And
based off of pure vibes alone, it's definitely still fine.
And then we can dry it, and then we can actually determine yields before I'm sad about anything. Let's get the numbers to be sad about rather than
sometimes your gut really is a better instinct than your brain in chemistry.
Weeks later, actually, it's been in the desiccator a long time. So
wow, look at that.
Nice,
it's like sand now.
And it is 103 grams, or just over 103 grams, which represents a 78% yield. I'm actually very happy with this, especially considering the fact that we ran the reaction twice. 78% yield is pretty good. I mean, I think it's a relatively high yielding reaction. And
a 78% yield of a very off-colored product.
Numbers, but especially on such a large scale, because the mechanical losses were quite high because I had such a big volume of solution I had to pour around and, a bit of spilling. 78%.
I mean, if you're not caring about purity at this point in time, you might as well just boil down the rest of the crap that you had,
caramel color.
Add it to this.
It's nearly a delicious color, kind of brown sugarish, but it's pretty crystalline.
Like cinnamon dust.
And I'd say that there's really not that many impurities in there, so it should be okay. In saying that, there's definitely a hair in there. Hold on. What's the hair doing in there?
Oh, you gotta remove the hair, Tom. That's the worst possible impurity you could have had.
Removed all the hair from it. But yes, it's great.
All right, Tom, show you good at chemistry. Pick all the impurities out by hand.
Than we made last time, which, once again, I keep saying it's great, but it's not that great. The point of this series is to do large scale, not medium scale. And 103 grams, I mean, we want 100 grams of cubane at the end of it. And we lost a lot of mass between our previous product and this product. And that's
he's gonna get like 10 grams of cubane. Isn't he?
That previous product, the tribromo, is just bromine. So we throw away 2 out of the 3 bromines, and that gets converted to sodium bromide, and we wash that away. So much of the mass of the product is lost. So, percentage-wise, we've got quite a lot of the product, but we lose a lot of mass in those bromines. And that's going to continue because we throw away those last bromines later on as well. So to get, even if we have very good yields from now to the cubane, which we're not going to
do. Oh yeah, he literally can't get 100 grams cubane now.
Enough product here to make 100 grams of
needs
cubane.
to do the reaction again.
We need to make more. Before we do this next step, which should be relatively simple, although quite time consuming, I want to make more of this. I really need to make more of this. But you say, how do we make more of this? We've just spent the whole series making this, and we've been using all the product all along. Well, in the background, I've kind of been running a second synthesis because I thought we might get to the point where we start.
He accounted for his own failures. He's learning.
So I've made some other stuff. I had to go all the way back to cyclopentanone and make some more cyclopentanone ketal, which I did off camera, made some more dioxane, and I have leftover bromine. So I have hopefully enough bromine to do another full scale run.
Oh good, he can do another war crime on accident.
Again, and end up with another 100 grams or so of that. And then we can do this next reaction with 200 grams. So I'm going to try and quickly smash it out. We've already done the bromine reaction before, so I'm not going to film it too much. I mean, I did the cyclopentanone reaction for the second time, and I didn't really film any of that, but I just did it because I just wanted to see if I could do it and do it.
Here's when the big bromine accident happens off screen.
One bit where I didn't add very much sulfuric acid when it was like refluxing in the Dean Stark setup.
Yeah.
And then I decided to add a little bit more, so I let it cool a little bit. I thought it cooled a lot, and then I added in some acid. It sucks that now I'm just having to describe what happened to you.
Oh my god. Hold on, I have to listen to that again. I was trying to half listen to what he was saying.
Let it cool a little bit. I thought it cooled a lot, and then I added in some acid.
Oh no. Yeah, so that's kind of always a hazard when you are using strong acids like that, is that if you let it get too hot, then well, adding more acid creates more heat, and more heat ends up creating more bubbling and frothing, and you get this situation where the entirety of the blackboard is just coated in acid droplets. The random equipment around is coated in droplets. The bench is absolutely cooked because of how much like paint or solvent has gotten into the paint and everything. This is why you don't do chemistry at home unless you're have a very strong reckless abandon for your own life.
It sucks that now I'm just having to describe what happened to you rather than filming it. But when I add the acid, the whole thing like flash boiled, and it went and it sprayed the walls and everything with toluene. This was like 2 months ago, but this got quite damaged, and even the paint. I mean, it looks pretty bad normally, but it got much worse.
Yeah, no, I could tell the bench was looking real bad.
Sprayed around. There's a video on Camolius's channel where another reaction does a similar thing to what mine did. So this is a recreation of kind of what happened. Yes, so I lost some yield that way. I feel a lot less stupid when things like that happen on camera because at least it's content. But when that happens off camera, I'm just like, I wasted all this product.
Well, Tom, the first thing you did off camera, you contaminated yourself with bromine. The second thing you did off camera, you contaminated the bench with toluene and acid. So, logically, now that you're going to do the bromination off screen again a third time, you're going to contaminate your entire household with bromine.
Hopefully less orange. I hope so.
Oh, good. He recorded it. He learned from his hubris. He didn't want to tempt the off-screen camera gods. Oh nope, you did spill a little bromine. Whoopsie. Oh yeah, you can see it on the ice a little bit. Yeah, no, that's not a very solid adapter. This is all extremely jank.
It was a new tribromo. It was on a little bit less of a scale, so slightly less cyclopentanone ketal put in because I had slightly less bromine, and I think the yields are quite a bit lower as well. Well, I know the yields are quite a bit lower, and that's probably because of all the bromine I spilled. But the product we do have is looking great, so we can now.
Oops! I accidentally spilled all this bromine.
A reaction that I've run 2 times already this video. Hopefully I'm doing nothing wrong with it, because otherwise I would have done the same thing wrong 3 times in a row. Anyway, let's do that straight away. Let's get to it. You know, no time to delay. Let's run this reaction and we'll come back when we finally have lots and lots of diels-alder product. Whole new batch.
Got a nice light beige at the bottom.
Looking good.
He really should just dissolve the product in the ethanol first, and then start adding the sodium hydroxide afterwards. That would prevent sodium ethoxide from building up and doing side reactions with the air and other contaminants. Ooh, it looks like mold. Delicious. Yeah, yum indeed.
And here it is, more of the diels-alder product.
Oh yeah, hey, that's a better color this time.
I thought they would
what
be
the
fun,
hell?
But I put them on and immediately started feeling like dank pods. You know, gonna arm that nug. I can't do his accent. He's too Australian. This is great. It's only 54.4 grams of product, which gives us an overall yield, well, the yield of the 2 steps from that ketal to here of about 28%.
Oh, abysmal.
This batch is 100 grams, and we started from the same amount of ketal between these two, so really there's an overall, I mean, it was slightly different, but an overall yield for those 2 steps of 53% or 52 or 53% for this.
Well,
one.
I mean,
However,
at that point,
you know,
I mean,
something does come to mind when you compare these 2 products. Yeah, this one is.
If you're already going with the brown in one, you might as well get the brown in both. Get higher yield.
Tari. So really the loss of yield is because I didn't scrounge much tribromo, so I didn't collect as much dibromo and carry that through the diels-alder product, which I think is what's causing this tar. But also the sort of involuntary spilling of so much bromine probably
Okay, yeah,
caused
that one's
the overall product
probably
to be
a issue as
unbrominated,
well.
but you know, only the tribromo crystallizes out initially. So yeah, I think that's what's causing our low yields for these two steps, because the diels-alder step, the step that we're actually meant to be doing in this video and focusing on, is fine. So no issues there. But anyway, so now that overall we've got just over 150 grams of material to go on with to finally do this second step for this video. I can't believe how long it's taken. It's been like 3 or 4 weeks.
Oh
Since
boy,
I had
now
made
Tom
this,
gets
and
to work
now
with
I've
sulfuric
got
acid
1.5
again.
times as
I'm
much, but it's
sure
lasting
this
3
is
or 4
going to go
weeks.
well.
This is not going at all well. I said weeks and weeks ago we have not much time, and now we have really even a lot less time. Anyway, I'm yapping on about not having time. God damn, we have to dissolve this in cold, concentrated sulfuric acid and stir it overnight. I was going to collect them all together because we need a reasonably large amount
Time to
of
draw the
sulfuric
molecules
acid,
while
but
he's
not
yapping
a
about it.
gargantuan size of sulfuric acid, so it will still fit in a 500 ml
I'm
flask.
not going to draw
I think
all
we
of
can
this.
bind all this together, or
I'm just
maybe
going to call
but
this
given the fact how
R.
tarry this one is and how untari this one is, untari, sure, how untari
Backwards
this one
tar
is, I might
celebration,
separate them
nice.
into 2 batches, so we'll run the same reaction at the same time, but in 2 different flasks, just in case this one really does go awful. But yeah, I mean, I'm complaining about tar now, but you ready for the sulfuric acid I'm going to use? A lot of you would know what the sulfuric acid already looks like, because yes, we're using drain cleaner as is.
Oh
Should be fine.
no.
I think this is what I
Using
used
his
last time.
dog
It was
shit
fine.
drain cleaner
So drain
sulfuric
cleaner
acid
as
again.
is. Let's get it out and have a look at it. Also, actually, first I gotta clean up this area. My gosh.
I've only seen
There is no
sulfuric
more space
acid
to do
more
chemistry
disgusting
here
in
at
my
the moment. It just
undergraduate
keeps
lab.
going. I won't show it all because
Well,
I'm embarrassed.
I'll wait
But,
until he
man,
actually shows the
let's clean up.
sulfuric
I can't
acid.
believe I've taken this long to do the reaction and the place is still dirty. Like, I could have been fast and messy or slow and clean, but I was slow and messy. It's
The
terrible.
worst of
Anyway,
both worlds.
moving forward. Isn't this beautiful?
Yeah, that's... Suffice to say, that's not pure sulfuric acid. Pure sulfuric acid is supposed to be a thick, maybe slightly yellow, clear liquid. That is a moderately thick, dark brown liquid that only occurs when you have really old sulfuric acid eating away at a plastic drain cleaner container for years. And I don't think that is even good enough quality to use. But Tom and many other home chemists managed to gaslight themselves into thinking, yes, this is a good quality reagent. This is still 98% pure sulfuric acid. I don't know how they managed to think that when it looks like this, but good on them. The only time I've seen, a tub of sulfuric acid worse than that was in my undergraduate research, where there was just in the lab a long forgotten about container of sulfuric acid in like some back cupboard that was much bigger and was much browner. It was real gross. Not a fan.
This is MoFlow, liquid drain solvent. Yeah, sulfuric acid, 1.83 grams per mil. Concentrated sulfuric acid, very dense. This is about 300 grams. It's about 550 grams of sulfuric acid, so they're quite heavy. Oh, even the clamp with the brick on it is... Ooh, not nearly as balanced as this was.
Yeah,
like
put some more weight on that,
here.
Tom.
Yeah, God, okay. Gonna need bigger bricks. Balance these clamps. The water bath is here because we need to get these cold, and we want to add all our diels-alder product into here while it all stays cold, and then we can let it heat up. Got some stirring here, that I'm trying to vaguely share between these two, so a little bit to sort out, but this is what the sulfuric acid looks like straight out of the bottle. Shouldn't be this dark, but it's got some dye in it, I think. I'm going to call it dye because that makes it sound like it's not a big deal. If I just say the sulfuric acid has tar in it straight out of the bottle, it doesn't seem as nice. But let's get this cold.
Yeah, no. You could say it's dye, I guess, but
so I'll keep reading
maybe it
this
is.
one and
Maybe,
that they're the
but
same, which is a terrible
I
idea,
think it's
but we're gonna do
absolutely
that
just
anyway. I also did a
organic
terrible job
crap that
cleaning up
has
this area.
gotten in there over time.
Alright, everything is looking nice and cold. We've got the 2 flasks here. I've got the frowny face one. Can't really see that. Frowny face one for the the Tari stuff and the smiley face one for a slightly nicer but
Alright,
still
and
yellow one.
then-
It looks all good, so we're set to go. We need to add in our powders into the mixture and then keep it cool. We don't really want it getting, you know, above a couple of degrees, which is why we've got all this ice. But once it's all added and stirred for a little while, we'll let it warm up to room temperature, which isn't too hot, and then let it stir there overnight. Before tomorrow, we dump it out into some water, and we should be recovering our nice product from there. Should just be a nice solid and all that. So nothing too stressful, even though usually with this much sulfuric acid and this much ice, you have a reason to stress because it feels like I'm doing a nitration or something, which are a lot more stressful because, yeah, when you start adding stuff, it gets so hot so quickly. But I think from what I've seen and when we did this reaction last time, the sulfuric acid doesn't really heat up too much when we add in our mixture, but we still got to add it all slowly. We can't just dump it all in at once. And we've got our stirring here. If you're very
don't
keen,
tempt
right,
fate
you'll
on
see
that one,
what
Tom.
this
You don't want to add too
stirring
much
thing
sulfuric at
actually
once.
tells
That'll
us how
absolutely
fast
blow
we're
up in your
stirring.
face.
Very
Like
weird,
earlier.
But I bought out someone else's home lab, and they were packing up a home lab. I knew them from many years ago, and they packed all their home lab up into a car, and I met them in a bloody shopping market car park, and bought all their gear.
Not shady
So I
at
got a bit of
all.
extra stuff. And this is the same as my hot plate, but the model up. Like, it tells you what temperature you can set it to, and then it goes to that temperature, and the stirring, it's not just a knob. You, like, set a number for it to stir. That's amazing. That's
Wow.
incredible. This
Man
there
is
hasn't been this
shocked
level
by
of innovation and shed science this
man is shocked
decade.
by a
That's
stir plate
just
developed
crazy.
20
I now
years
not
ago.
only have one hot plate, I have two, but one that actually has a temperature dial. Wow, that's amazing.
Probably still not that
At any
accurate.
point in my life, I could have bought this hot plate. Could have got the upgraded one, but I've just stuck with the base model. Anyway, not to get all too fancy for you, I see these comments that are like, oh, don't buy nice gear. It's fun you struggling. I love to see you suffer. Don't worry. We're still going to suffer, even
He's
if
going to
it's
suffer.
just marginally
His methods
easier,
will
because
ensure
now
that.
I can set a temperature. I don't know how accurate it is, but you can actually even put in a bloody external probe in the back. How sick is that? It's not mint condition. But
It's like a VGA port in the back, what, so you can plug it into your computer?
For the cost that it would cost me to buy one of these hot plates brand new. In fact, it was
Okay,
probably
that
less.
is pretty honestly
Anyway,
expensive.
sick. My powers continue to grow. All right,
1.5K on a
I'm
hot
Let's
plate
bloody
is,
get this done.
I don't
Let's
understand
go.
why hot plates are so goddamn expensive. I guess they have to have a pretty strong magnet in there, so maybe the neodymium magnet is, like, pricey, but, like, I don't think that it needs to be 1.5K expensive. But anyways, so the basic reaction that's happening, and I'm probably a little bit wrong on like the byproduct here, but basically the oxygens on this diketal, they go ahead and they absorb a proton from the acid, which kind of causes a bit of a chain reaction to cause one oxygen to get kicked off by the other, and the one that is still remaining tethered to the big organic group that I have denoted with the letter R. Ew, that is tarry and disgusting. That is like you just pulled that right out of your engine or your asshole, whichever image you like less. The remaining oxygen gets its electrons back through some assistance from the conjugate base of the acid, and there you go. You get your ketal lopped off and a ketone remaining.
I am powerful.
Yeah, yes, Gabriel, exactly. Thank you. That is the exact kind of analogy we're going for. It is very poopy. It's very poopy chemistry hours this time around. All right. And again, he's doing maybe this little counterintuitive, but he's pouring this off into water, ice water, in order to in a controlled and cool temperature manner, crash the solid out of solution. And kind of lo and behold, he's actually getting something not that bad.
I ran out of spoons, okay?
Off
Don't
brown.
judge.
Oh my god, he's using the flat of a...
All right, and after many hours of filtering,
I don't understand why after so many years he just doesn't invest in like a metal spatula. It costs like $12 on Amazon to purchase a metal spatula for like scraping stuff. He doesn't need to keep using plastic spoons and pipettes and forks and knives. Just buy some metal equipment, dude.
We have 3 lots of solid. Both of these are from the 100-gram run. The
Even if you want to keep the hardware store aesthetic, you could probably just like buy a piece of like stainless steel from the hardware store, like a tube or a sheet or a thin rectangle's worth of like stainless steel from the hardware store. You could use that. Anyways.
One, and it ended up being a bit of a brownie grey solid, and from a happy face one, we sort of brownie orange. We got a lot of solid and a lot of piss coloured liquid. The god of tar
piss
wears many faces, yet he is always recognisable. Yeah, we're going to have to get these super dry before we start doing the purification step, because I think the water will interfere with the purification step. Maybe not super dry, but I don't want to wash these with ethanol.
Well, you got a desiccator now, so
it'll just dissolve too much solid. And we've washed it with a bit of bicarb and lots of water, so we've gotten rid of the sulfuric acid. But it's just a matter of leaving these on the pump to try and draw off as much water as I can, and then putting it in the desiccator. But before we get to all that, my mind is going to the next step already. Step 6. This is the little step I'm worried about, but
that's gonna be an interesting video. That man tried a reptile lamp for the longest time.
There's 2 paths.
It is not pretty.
The flow path, and the other path I will call the jug path, alright? So this flow reactor, we have to expose this solid to a large amount of UV light with a little bit of photosensitizer in it. And the idea is to not let it get too hot and, you know, not overexpose it too much. So the best way to do that is a flow reactor, right? So flow reactor in the sense that you have your liquid, you know, your solid dissolved in a solvent, and you pump that through some tubes. The really
it
thin
flows,
tubes, so that the
it
solvent
goes
gets
past light,
heaps of UV
and it keeps
light,
flowing.
'cause you've wrapped
It's great.
those tubes around the lamp, and then it comes out into another bucket, and that bucket is perfectly filled with solid that you want, well, you know, in the solvent or whatever. So you've done that reaction through the tube, which sounds really good and has the advantage that it's really quite scalable. So even if we had 1 kilo, 2 kilos of this material, we would just have more solid dissolved in the solvent, and we just run the reactor for longer. It didn't really affect how much each molecule
it's just that it
gets exposed
requires
to the UV,
mechanical know-how
through the same tube. We just run the
and
reactor.
a lot of
so it's
setup.
scalable, and it's very cool. So those are the advantages. The disadvantage is that I don't really have a good way of calibrating it, because I can't really test very well at the moment the end products. If we run it through the reaction and say we only get 60% conversion, how do I know that? You know, maybe I'd be able to tell, oh, it hasn't fully converted, but how would I be able to tell the difference between, say, a 10% conversion and a 90% conversion? You know,
Didn't you do thin layer chromatography last time?
You know, what's the path length?
You can probably tell if you have a different compound, if you did the thin layer chromatography last
time. It's a lot of
time.
engineering. It's complicated. Well, it's not that complicated, but, you know, I got to build
Take
this
a
thing.
drop of your solution and run it up a plate and see how far the drops go.
What am I changing, you know?
See what your product is.
Flexible so I can increase the path length or add more lights if needed. I don't know. There have been some good papers on this subject and some YouTube videos of people doing this exact thing, this cubane flow reactor.
Because everyone beats you to it.
This jug method where you just put the stuff in a flask and blast UV through it for a couple of days, which is what we did last time, Kamolius did last time, and and there's even papers now.
Kind of a miserable process.
This way with the LED panels, it is simpler, doesn't scale as well, but people are still doing it on a reasonably large scale. And even if we had to do multiple flasks, or, you know, a flask and then, you know, do 3 days and then do another flask while we do the other one, that it's still quicker than doing this whole build project to a flow reactor. So the jug method has that advantage in that simplicity, in that we can just see that conversion, and if it's not converted and we have a way of saying, you know, testing it and saying, oh, it's not fully converted yet, we just leave it in the reactor longer, and then we come back in another day and then check it again.
Well, that was the exact same thing in the flow reactor.
These random variables that we can't really calibrate.
You could just say it happens for another day.
It's so much less cool than a flow reactor. So which way do you see me going? Sorry for yapping on so much in this video, but there's just a lot to think about. And rather than thinking, I'm just saying these thoughts out loud, because you guys often have better ideas than me. In fact, nearly always you have better ideas than me, but it doesn't mean I don't follow my own ideas, because got to respect a bad idea every so often. All right, this is fantastic. Let's keep going. Come on. Let's get some dried solid of the diketone, the deprotected diketone. Let's do it. All right, I'm using the big pump to just suck through the last of the water from this sample. It's not the most ideal to...
I guess if I were to weigh in on the jug versus flow chemistry, debate that he's having with himself there. I mean, I would, as much as I'm shitting on it, I would probably still go with like kind of the quote unquote jug measure or jug method, just because I don't have a good idea in mind of like how would you actually set up a flow chemistry reaction. You would need the special glassware and the tubing for it, and it's just a feat of engineering that is not something I am very adept at doing or experienced in doing for my own research. Um, I suppose the only thing I would say is just that, yeah, he can, regardless of which method he can just test for his product with thin layer chromatography. He's done it once before. He had DCM stains because he was using DCM with some shitty plastic, and it was dissolving the plastic and making fake data points. But if he just corrects for that and maybe gets like some glass pipettes or something, he could probably do it correctly and not worry about, not knowing when his product is done, because he could figure it out pretty easily with that method. I would just only think like if he's doing the jug method, it's just he needs to actually have, very good stirring, add quite a bit of photosensitizer into the solution, so that way you can actually get the reaction to happen at a reasonable rate, and have just really bright LEDs on it, or make sure your glassware is transparent to it. It just needs to have time to go. Like you cannot rush it. Photochemistry is it is environmentally friendly and does not require doesn't make too many side products. You just need to be patient with it. You need to give the light a lot of time to soak into your product, so to speak. I think if he does a jug method, it'll be fine. It just he has to. I don't remember what his UV setup exactly was as of last time. And if he's going to, I swear to God, if he cheaps out and tries to buy like 70 reptile lamps again and says, surely it'll work this time, guys, I might scream. But if he just actually buys, many LEDs again, he could make it work.
Pull water vapor directly into this oil-based pump, but she'll be right. She can take it. She always does.
That's the crappy
fine.
pump you don't like
heat it
anyways,
too much.
Tom.
It sucks to go this far and then put it on a hot plate and then burn it or make it all char up or tar up just because I'm.
Did you have a desiccator you could use? Okay, okay. No, he's got a baking sheet. This makes sense. Absolutely the messiest. Ew. God, that batch is still chunky. Oh, and then there's the desiccator. Sweet, to get the rest of it off.
Here we are after a couple of days in the desiccator. We ended up with a 78% yield on the smaller scale, the one that we thought was going to be worse. And on the large scale, we ended up with a 92% yield, which is fantastic.
It's like the highest number I've ever heard out of him.
Stop the timer and look at a world record speed run of 62 days for these two steps. A lot of things went wrong with these two steps, but I can't help but shake the feeling that if I was a little bit more organized, I probably still could have done this all in a couple of days. But then again, if I was a well put together human being, I probably would have been making tiny molecular cubes in my shed. So next up,
fair enough.
The purification.
Being unhinged means you make good content.
Put it through the photo reaction. However, we're gonna do that. So you better subscribe, and I'll see you all next.
And man, I'll see you all next time.
Oh, what's this? A bonus at the end? Does he have a snake now? Okay, that's new. Never seen a snake on this channel before. But, yeah. Hopefully that video was enjoyable for everybody. It was, lots of brown, lots of poopy color, and, I don't know. I think it was fun still. I personally, I cannot wait for him to do the UV step next, because, oh my god, that was a this was a disaster on the small scale for him. Like, this step alone, figuring out just something to get him going through the rest of this, like, this straight up took him, like, 6 videos or more to do, and, like, that took a span of, like, a year just for those 6 videos. I cannot fathom how this is going to go on the large scale because of how difficult this was on the small scale for him. This is going to be maybe the struggle of the century for chemistry, and I am all here for it. But I think for tonight, it is a nice short stream. We just had the one thing to react to, so I am no longer here for tonight. I think I'm going to be signing off. Thank you all for lurking as I talk madly about the one subject that I truly love. And I will talk to y'all later. I am going to take a break next week. I need to set up the hey score bar. Sorry, it might have been the wrong time to join. I'm actually heading off for the night. But no stream next week. I need to set up thumbnails again. And I also need to what was the other thing? I needed to, like, oh yeah, get organized for like the next games, like actually test them, make sure they work, and all the other yada yada nonsense. So plus I could just use some time to, I don't know, have some scheduled in break time, so I'm no longer going for like 4 months at a time without a week off of streaming. So I will talk to y'all in the Discord later. If you haven't joined the Discord yet, it's down in the description. Go ahead and click that link. Do all the other stream interact stuff because it's, you know, good for my psyche when you make the channel's numbers go good. And I will chat with y'all in the Discord later. Have a good night, everyone, and I'll talk to y'all when I see you next time. Bye.